Okay, the structure of the atom. J.J. Thomson. So he proposed the existence of electrons using cathode-ray tubes. And the electrons are a negative charge, and he said that the atom then must also contain positive particles that balance the negative charge. We now call those particles electrons. So the atom has electrons in it that have a negative charge, but overall the atom has no charge. So if there's negatives, there must be some positives to balance those out. So here's a picture of the cathode ray tube. It's a lot like a fluorescent lamp. So here there's a gas inside, and you apply an electric voltage across it. And so electrons come in here and they form a beam of electrons that go through this gas. And when they do that, they cause the gas to give off light energy. Not going to quiz you on that either. Can we do it? Yeah, we have a couple of those. We could do those. Yep. So Thomson came up with a model of what he thought the atom looked like. Has anybody ever had plum pudding? Have you heard of plum pudding? Some of you have at least heard of it. It's a British dish. Some of those Europeans, they eat some strange things. This is a picture of plum pudding. Okay, I don't know. It looks like carrot cake or raisin bread or something like that. I think the closest thing we have, to think of it in terms of this model would be like a blueberry muffin. So think of a blueberry muffin. So there's this blue stuff here, there's this uniform positive charge. That's like the bread part of the muffin. And then it's got these electrons scattered throughout that are negatively charged, and those are like the blueberries. Okay, so you've got this, this white cakey stuff with these blueberries in it. That was his idea of what the atom looked like. Because they found these electrons, and then they said, well, there's got to be a positive charge, and then, well, how are these things put together? And so these were the early days of trying to figure out what's inside the atom. And then Ernest Rutherford in 1911, he was actually a student of Thomson's, so he worked with Thomson, and he was actually set out to confirm Thomson's plum pudding model, but he ended up disproving it and coming up with a theory for the nuclear atom. The nuclear atom, now this is a completely different picture of what the atom's like. It has a small center of positive charge called the nucleus. And it's really, really dense. And then the electrons are traveling around that nucleus at a fairly large distance. In that nucleus, you have protons, particles that have positive charges, and then the electrons have negative charges. So the charge on the proton is the same size as the charge on the electron, but it's opposite in sign. So you've got positives and negatives, and then they balance each other out. Then Rutherford, didn't stop with that one big thing that he did. He continued his work, and working with Chadwick, they discovered another particle in the nucleus. It's a neutral particle called the neutron. So the proton is positive, the neutron is neutral. You think you can remember that? And then the other one is the negative one, the electron. So the neutron is slightly more massive, essentially the same size though, but no charge.
Other than giving more mass to the particle, what does a neutron do for the particle?
What does a neutron do other than providing mass? That's a good question. We'll find out that isotopes vary based on the number of neutrons. The number of protons is the same, the number of neutrons are different. Some isotopes are unstable and others are stable. And so apparently having more or less neutrons can make the element unstable. That's a good question. Okay, so let's just summarize this. I thought there was a slide on it, but there's not. So protons and neutron and electron. And we typically abbreviate proton as a P, neutron as an N, and electron as an E with a superscript minus. The charge on these, the proton is +1, the neutron is 0, the electron is -1. And then the masses, 1 atomic mass unit, and we'll talk about what that is later. It's just a unit of atomic mass. Yeah, very cryptically called the atomic mass unit. And the electron is essentially 0 atomic mass units. The protons and the neutrons weigh almost 2,000 times more than the electron does. So to put it in terms that we could maybe understand a little bit, if the proton had the mass of a baseball, the electron would have the mass of a grain of rice. So really, really small. And to give you an idea of the kind of the scale of the atom, if you had the nucleus be the size of a pea, those little green peas that your mom tries to make you eat, and you put that on the 50-yard line of a football field, the edges of the atom would be at the goal lines. It would be a sphere 100 yards across, and the center is this green pea. And then you have these electrons that are 2,000 times smaller than the green pea, kind of zinging around in that big empty space. So I'm telling you basically that this bench is mostly empty space. It is. Doesn't look like it, but it is.
So do they all have density?
They have density. The reason that matter has mass is because of the protons and the neutrons. But they're all squished together in the middle in the nucleus, and then there's all this empty space around it. If you were able to take the nuclei and put them together, which we can't do, but if you were able to put them together and make the size of a period in your textbook, make a sphere that big out of pure nuclei, it would weigh millions of tons. That's how dense the nucleus is. It's crazy. It's
But
crazy.
what about the electrons?
The electrons are much, much smaller, and they're occupying this huge volume, and so their density is incredibly small.
So does that mean it's heavier?
The nucleus is much, much heavier than the electrons.
Does that mean like a proton?
A proton is heavier.
Compared to an electron?
Yeah, so a proton is 1 atomic mass unit. The electron is essentially 0 or 1/2000th of an atomic mass unit. It's so much smaller that we can a lot of times just ignore that it has any mass at all. It's kind of crazy.